Hello, Algebra 2. Let's talk about the last section of Chapter 2. It's Section 8, all about graphing linear and absolute value inequalities. Front of the page is all about the linear inequalities. Back half of the page is all about the absolute value inequalities. So this video, we're going to focus on the linear ones. Linear, we know that's a parent function. It means they are a straight line of some variety. So there are a couple steps that we're going to take, and actually this follows for the absolute value inequalities as well. So here we go. Step 1, graph the boundary. The boundary for these is just sort of like a fence. It's not the answer. Normally when we graph a line, the line is the answer. For these, you're always going to give me a picture, right? So there's no answer as no number as an answer. It's always a picture as the answer. So we're going to graph the boundary. Like I said, it's like a fence. That is the related linear equation. So we're going to graph these inequalities as if they were lines. But we have to consider the fact that they are inequalities later. Right, like the very next step is if the inequality symbol is any of the ones that have the or equal to attached, the boundary line is going to be solid. When we graphed inequalities on number lines before, just like one-dimensional number lines, we would use a closed dot to represent this situation. Well, on a line, a closed dot is a solid line. If the inequality symbol is just less than or just greater than, the boundary is dashed. That's the equivalent of our open circles that we would use when we did inequalities on a number line, or we've also used this notation when we did piecewise functions a couple sections back, so keeping those in mind. But since it's a line now, it's either going to be a solid line or a dashed line. Then we're going to choose a point not on the boundary line and test it in the inequality. And we want to make sure that a true inequality results. If we can get a true inequality, we are going to consider that as an answer to our linear inequality. And all of our answers are going to be on that side of the boundary line. Take a look at this first example. You'll see what I mean. And these might be familiar to you, right? So this one, since it's a greater than or equal to, I needed a solid line, and I have that right there. Also, I have a pencil handy. I'm not just using my markers today because we're going to shade a lot on these. When they graphed it out, they graphed the line. Again, we're not going to go through that real quick right now because you guys should be able to graph a line at this point. But when they figured out that it was actually a greater than situation, y is greater than or equal to stuff, they shaded above the line. Greater than, above the line. So that's the upwards direction here, above the line. Another way you could figure that out, though, what the steps above we're talking about when you're testing a point. I see, for example, that the point 3, 2 is on my, not on my boundary line, but it's on my graph. This point, which is on my shaded region here, is a valid point in my original inequality that they gave me. But I want to test that just to be safe. So here we go. Originally I had x plus 2y is greater than or equal to 4. I should be able to plug in the 3 for the x, the 2 for the y, and get a true statement. I get 7 is greater than or equal to 4, which is true, which means I am shading the right direction. I've shaded the correct direction. 3, 2 is an answer to this inequality. It's a solution. Let's do a few more. Some of them we can graph right away. Take a look at number 4 down here. Number 4 we can graph right away because the y is by itself. Once the y is alone, it's going to be in mx plus b form, and we can graph it really easily. Notice here I have x over 2. That's the same thing as 1/2 x minus 4. So minus 4 is my y-intercept. 1, 2, 3, 4, up 1 over 2, up 1 over 2, down 1 to the left 2. So there's my line forming. Now, because it's a less than symbol, I am just going to use a dashed line to connect those. And because it is less than, I'm thinking I need to shade below, but I'm going to test a point just to be safe. Let's test any point. In fact, let's do a bad test to show you what a bad test looks like. Let's test this point up here, 0, 0. It's nice to test 0, 0. The math is really easy. So it should be able to fit in my original inequality and be correct. So if I test 0, 0, I should be able to say 0 is less than 0 over 2 minus 4. Well, 0 over 2 is just 0. Is 0 less than negative 4? Nope, that is false. Meaning this point is not on my answer side. It's not in my solution region. So this side over here is my solution region. If you have any single bad test point on that side, your shading is not on that side. So again, we call this the solution region. Cool. Okay, let's do another. How about 3? Let's go for 3. I'm going to need to finagle the numbers just a little bit here. I'm going to subtract that 4x off to the other side. I get y is less than or equal to negative 4x minus 1. My y-intercept is negative 1. My slope is negative 4. Remember, that's negative 4 over 1. So down 4, 1, 2, 3, 4, to the right 1. Or up 4, 1, 2, 3, 4, to the left 1. I see my line forming. This is less than or equal to, so I'm going to do a solid line there. Try to make it as straight as you can. Okay? Now, a graph like this, it might be difficult to see what's above, what's below, but always think, go to like a single point, right? A single point, maybe I pick this one. Right here, above would be this way. Below would be this way. So I'm supposed to be going less than, so I'm thinking I'm going to shade down. I'm going to pick a test point just to be safe. So let's test. In fact, look, 0, 0, again, I'm thinking it's on the wrong side, and that's fine. But 0, 0 is nice to test if you can. But just pick a point that you know is not on the boundary line. It cannot be on the boundary line. When I test 0, 0 in my original, 4 times 0 plus 0 is less than or equal to negative 1. Well, this whole side just equals 0. Is 0 less than negative 1? No, that's false, meaning that point was a bad point. So I don't want to shade that way. I want to shade the other way, which is all over here. So me shading is essentially me saying that's an answer, and that's an answer, and that point there, and that point there. All of these points are valid answers. They're valid solutions to my inequality. But I could sit here forever and dot all these points because there's an infinite number of points in this region. So as opposed to me just sitting here and dotting all of them, we just shade. It accounts for all of the points that way. Let's talk about the last example I want to do today, which is 6, because everyone loves decimals. So let's talk about this one. Again, I need to finagle it a little bit. I'm going to subtract the 0.5x off to the other side. When I do that, I end up with the negative 0.25y is still there, less than negative 0.5x plus 1.5. I can fit it on the paper there. Hooray. Excuse me. You could go for fractions or keep with the decimals at this point. I'm going to switch over to fractions, mainly because I don't have a calculator next to me right now. So, wait, I have my phone. That's a calculator. Hooray. I'll do it both ways. If you're into fractions or if you like, excuse me, fractions or decimals, your call. So, what I would do is I would just divide both sides by negative 0.25. Now, don't forget, you just divided by a negative, meaning your sign, your inequality sign needs to switch directions there. So I'm going to have y is greater than negative 0.5 divided by negative 0.25. I get 2. How nice. X. Then I have 1.5 divided by negative 0.25. I get negative 6. How nice. If you had done that in fractions, you would have had negative 1/4 y is less than negative 1/2 x plus 3 over 2. If you would have multiplied everything by -4, that would get rid of your 1/4 here. Distribute to everything. You get just a single y is greater than, because you multiplied by a negative. -4 times -1/2 is your +2. -4 times 3 is going to be -12. Divided by 2 gets you that -6. So either way. And when we graph this, we're going to start down at -6. 1, 2, 3, 4, 5, 6. My slope is 2. So up 2 to the right 1. Just like that. Dashed line on this one. A good point to test again would be 0, 0. And don't forget, we flopped the sign here, so I'm thinking it's greater than, I'm thinking it's above. So let's test 0, 0. I'm going to have 0.5 times 0 minus 0.25 times 0 should be less than 1.5. Well, everything over here just cancels to 0, which is less than 1.5, so that's true. So my answer, my solution region, is everything over here on that side of the graph. And we are done. So that's all about graphing linear inequalities. And we're going to talk about graphing absolute value inequalities on the back in the next video.